Hey, welcome back to Common Sense OT Security. Today we talk again about one of your favorite topics, which is the Purdue model. I know you love the Purdue model, but struggle to understand what it actually is and how it can or should be used in OT security. So that is what we're going to clear up once and for all today. And I will structure or design my topics around, or I will frame it for IT folks, not for control engineers, because they are usually not that much interested in the Purdue model, or they know all about it already. But apparently, IT people think it is really worthwhile to obtain a full understanding of that model, and also maybe put it to good use for OT security. So this is what we're going to do today, and we start out with a very simple Google search. So if, and I think probably you will have done that already, you just Google for Purdue model, and this is what you get. I just did that a couple of minutes ago, and the AI tells us it's a foundational hierarchical framework for industrial control systems that organizes operations into distinct levels to guide network design, security, and management. If you ask me, that is a stretch. That is something that you can interpret into the model, and certainly many scholars do that, but we will cut through the horse shit today and try to set things straight. But what I really want to focus you on is, if you just look at that first Google page, so and you look at the links that are provided in more detail, what do you recognize? What is the Purdue model for ICS security? What is the Purdue model for ICS security? Funny thing is, I didn't even mention that I was interested in ICS security. So this is just something that the AI had provided. And apparently, because that's the context in which this term is discussed most often. Zscaler, what is the Purdue model for ICS security? Department of Energy for industrial security, blah, blah, blah. And if you ask me, I find that rather non-intuitive. So we just wanted to learn about that abstract term or concept, and now we are knee-deep in ICS security. And that doesn't make a lot of sense, and I will explain why. But before we go any deeper, I believe one reason why you're also interested in this, or to learn about the Purdue model, is because the details go all over the place. So just 2 days ago, there was this LinkedIn post by Bharat Chandel. He gives us an oil and gas example for the Purdue model. And this is the diagram that he provides. And what I think is noteworthy is, just look at that diagram here. What about level 3? Level 3 is missing. There is no level 3. Site manufacturing is at level 4, that's creative, and level 5 is enterprise and business systems. And I would just imagine you have encountered that already a couple of times. Now, if I just pick another model, this time by Palo Alto, and we're going to focus on this particular one a little bit longer, guess what? That's totally different. So their level 5 is the internet DMZ. Level 4 is enterprise administration. Level 3 is ops admin. So how is that? And again, this is something that you will notice frequently, that if you just try to understand or to go to all these scholarly articles and all those diagrams, well, they don't seem to agree a lot, which is really amazing, because the model as such is not very difficult. It's actually quite simple, and we're going to the bottom of it. So let's focus. We are just going to use this model from Palo Alto. Let's focus on the guys from Palo Alto. Unfortunately, they right away put it in the context of ICS security, which is not where it comes from, my friends. No, it is just, so let's get that out of the way. So what is the original intent of the Purdue model? It basically gives you an easy way to learn about the various device types in OT, in factory automation, if you will. That is what it's all about. To make it easier to understand what a PLC is, for example, what an actuator is, because if you put it in those levels, sometimes it's easier to figure out, okay, I see it. This that down there at the bottom, that's the actuators. So it makes it easier to memorize, but it was never intended as a way to structure your network architecture. And unfortunately, it is abused heavily. And you will learn today why this is a very, very bad idea. It's a terrible idea. We will get to that. But first, again, let's just go through those various device types. Okay, so what I think for IT folks makes OT a little bit difficult to understand is that we're not talking about switches and computers only. We're also talking about these very exotic devices such as PLCs and actuators. And just for starters, so an actuator is a device that actually transforms energy and matter. Okay, so when you are talking about actuators, you're no longer talking about low voltage devices. This is where physical energy is used to manipulate matter, as an example. Okay, or just to use energy to facilitate the production process at hand. And pump, by the way, is an actuator. I don't know why they list it separately. And sensor, that is the other category at the bottom. So sensor is simply as your thermometer in the household. That is the device that measures physical reality, such as degrees Fahrenheit when you read the temperature. So you have that in its own category, if you will. And in Purdue, you call that the level 0. You could also call it level A or whatever you like, right? And then you have the control level or category where you find the PLCs, and most people also include the RTUs here. This is where you have some kind of automated control over those actuators, and the actuators are manipulated in real time based on the sensor values, as simple as that, okay? So you could say, in a way, your HVAC at home. There's a very, very simple control system where you have the thermometer, you have a controller, and you have an actuator. Okay, so when the temperature gets too high, then the actuator makes sure that cool air is produced and pumped into your living room or wherever you have that thing. Then over here in the next level, you have PCs and HMIs. Very simple. Industrial PC is basically a rugged form of your desktop, if you will. And an HMI, that is the tiny little thing where you just have an operator panel, where you don't have necessarily a regular keyboard and a computer screen. It might just be a small thingy where an operator types in some numbers and can read some readouts. Okay, then next you have a couple of servers here. So from here, level 3, it's pretty much very, very similar to what you know from your IT environment. And that is basically what the Purdue model is all about. So there is no inherent wisdom in there, in those layers. It just helps you to conceptualize all those different types of equipment that you will see in factory automation, and it will hopefully help you to better understand what this is all about. So what the differences are compared to your regular switches and computers. And then, unfortunately, usually you will. So unfortunately, the vendors or the media or I don't know the Science Institute doesn't stop there, and they imply that now all kinds of important stuff is going on and can and should be connected to those layers. And now you're veering off into the weeds. And I don't want you to make that mistake, my friends. This is why I'm doing this webcast. So this is all stuff that you can safely ignore. So don't waste your time on Purdue. So what you have learned so far is basically it. You don't need to know anything more. Everything else here that follows is irrelevant nonsense for IT people. It will not teach you anything. Now we're already at the threats and the outdated systems and the vulnerabilities. Nothing of that has to do with Purdue. And now we're in the malware, etc. Nothing has to do with Purdue. And now let's ask ourselves what is the problem with that model. So first of all, the big problem is it wastes your time. As simple as that. I don't want you to waste your time. So many newcomers to OT security just spend days trying to understand the wisdom behind the Purdue model. There is no wisdom. And I think they are spending days because they are seeing all this conflicting information. Somebody tells you, the level 5, that's the site level. Then the next person tells you level 5, that's the internet or the internet DMZ or whatnot. Okay, and now let's focus on the problem with the Purdue model, but in the context of OT security. Other than that, I don't necessarily see a problem. That it's mistakenly used to make you believe, well, it can and should also be a guidance for network segregation, and it would have some relationship with IEC 62443. And I'm very happy about this one comment here from my friend Eric Kosman. Let's just quickly go back to that LinkedIn post. So with the missing level 3, Eric Kosman, in case you didn't know, was a longtime chairman of ISO 99. ISA 99, which is the predecessor of IEC 62443. And Eric tells our friend, well, it no longer explicitly use the Purdue model as reference model. And so most of you will already know this. 62443 has replaced that with zones and conduits, which makes much more sense. And you will see why in a second. So the area where things get fishy is when people suggest, well, this can and should be used for network architecture and network segmentation or segregation. And you will understand within the next, I don't know, 10 or 15 minutes why that's a stupid idea. But let's begin with the question, what is the objective of network segmentation? Just think about it for a minute. Why do you want to introduce network segmentation? And I could add as some context, many asset owners are still using flat networks. Not deliberately, because the whole thing, that's a technical term. It has grown organically. That means nobody really applied some kind of direction or policy. Nobody cared, and all of a sudden, our network is pretty big, and people are realizing that this creates issues, security issues, And therefore, this whole idea of network segmentation comes in. Now, to make it very simple, the objective of network segmentation is to prevent propagation of malicious commands of malware, etc. So you want to contain the threat, if in modern parlance, okay? And if you didn't know that already, you can also, again, simply ask your good friend Google, where you would learn in a second that the main objective of network segregation is to improve security by containing threats, preventing the lateral movement of attackers, and protecting sensitive areas, blah, blah, blah. So that is the objective. And now let's try to understand how the suggested way to segment your networks, suggested by the Purdue fanboys, how that is going to end up, what this is going to yield. So for this purpose, I have copied the model that I've shown you earlier from Palo Alto, because, I mean, in a way you could say it's one of the better graphs, one of the better diagrams, because it avoids a couple of serious mistakes. And if you closely look at this diagram, you see, maybe most importantly here, this big ass firewall between the level 3 and the level 4. And that is probably the only idea that you should or could take away from Purdue as far as network segmentation is concerned, because that is something that you regularly find in those scholarly articles, that there should be a division between IT and OT. And IT is usually called the level 4, whereas everything below is considered OT when you have all these exotic device types, etc., and when you're talking about real-time process control. So that is usually a consistent idea. What you would also usually find is that this is not just a firewall, but it's a full-blown DMZ, and that DMZ is usually called level 3.5 because it was missing in the original Purdue models, and because it was never intended to be about network segmentation, okay? Why does Palo Alto not pick up this concept? I don't know. Funny thing is they do have it on that website that I've shown you. So there also is a small video where they're using a slightly different architecture with the level 3.5. So this is something that everybody should take away. Why? Because still today, there are lots of asset owners where there is no really dividing line between the enterprise network and those process networks, and that's bad, right? Because in the enterprise network, you have all kinds of traffic that you don't want to see in process networks. And if you go further down here, then the next level here is those that second firewall level, where we see three firewalls, and that is maybe the best thing that you can take away from the Palo Alto documentation, if you will, that they are now starting to do an east-west segmentation. Okay, so not just north-south, but they are doing east-west as well, and for some funny reason. Or maybe just because they are smart at this point, they are not extending this downward. Okay, we'll get back to that point. So I really like this architecture. And down here, then you have DCS system. That is a distributed control system. That's the acronym. That is not necessarily something that you will always find, because DCS is our thing in the process industries, where it's about liquids and gas manipulation, etc. You will not find a DCS in manufacturing, discrete manufacturing, where you're producing pieces, small little pieces, or even large pieces, like in automotive manufacturing. But they don't use DCSs, then you will not find that term there. But that doesn't matter. I think the idea, and this is actually, in my opinion, easy to understand. The idea is, so you have different production entities. And now it gets interesting. Okay, why would you want to separate those from a network access perspective? Well, I think so. If you think it through, it becomes fairly obvious. If you would consider that one of these functional entities, which you could call a work cell, or you can think of a manufacturing line, if any of those entities get compromised, how, why? Well, maybe a contractor comes in with his malware infested laptop, wants to do a firmware update on those PLCs, and then bang, you have that whole functional unit compromised. That functional unit then goes down. So you get unscheduled downtime. And wouldn't it be great if that damage would be contained in that specific functional unit? And at the same time, those other units are unaffected. They can continue to produce product. And that is the whole idea behind network segregation in OT. And why do I point this out? Well, again, think it through. The problem for IT folks usually is you will not be able to arrive at useful network segregation without understanding the functional dependencies. Without understanding, well, that particular machine line, what is actually part of that machine line? What is required so that this machine line can function as an isolated unit? Okay, that is not something that you would be able to identify just by staring at the HMIs or by staring at the network switches. So that is something where you need the help and the knowledge of the control engineers. And unfortunately, IT and control engineers, they're usually, they are not best friends in most companies. And if you don't have that knowledge, if you can't acquire that knowledge, you will never be able to really do a good job in network segregation. And because, maybe just because it's so difficult, many experts make the huge mistake to simply go with the Purdue model, or what they think the Purdue model will tell them, and they do a horizontal segregation, or at least they advocate a horizontal segregation, and that would then probably look like this. So first of all, you would say, and again, so now this is my modification of Palo Alto. This is not in the Palo Alto stuff. They were intelligent enough to leave that part out, but you will find that in other reference documents, right? So you just use another uniform firewall across that whole level. That's a bad idea. That's a very bad idea. Because if any of these work cells or functional units get compromised, it will affect all these units. That's the problem with horizontal or north-south segregation, right? And so what you're looking for is you want to prevent that lateral movement, and that requires you, unfortunately, to do a functional analysis. So maybe the worst idea would be what I have modeled here, is where you also introduce another set of firewalls or filters within those routers for those lower levels, which is something that some Purdue experts advocate, and which in a nutshell is complete nonsense. Because First of all, if that, let's just say that PC here in that rightmost functional unit, let's just say manufacturing, machine line, if that is compromised, that whole machine line will go offline, no matter what. So it's actually, it really doesn't give you anything to also segregate those PLCs and the actuators. By the way, in case you didn't know, the actuators are networked also. That is the idea that everything, that all those devices at level 0, they would be hardwired and analog. No, that's no longer a thing. So you will find network switches down here as well, and some people might have the idea, oh, let's also introduce a firewall on there. That is a bad idea. So you will not efficiently contain the threats. You will promote the propagation of the threat. And that's the exact opposite of what you would want to accomplish. And so therefore, well, bad idea. The only thing that you should take away from Purdue is that big firewall up here, which is usually called 3.5, and which should be a DMZ, which is more than one firewall. So that will give you a lot of bang for the buck. But certainly you will most likely want to do more, because everything below that DMZ, well, you might be talking about tens of thousands of devices. So if you look at a large manufacturing plant, it might easily contain 20, 30,000 devices, PLCs, RTUs, actuators, you name it. And certainly for that purpose, you want to do your segmentation. Some people also then call it micro segmentation. That is an awesome idea, because network security gives you the most bang for the buck in OT security. Why? Because all these devices below that level 2, they're insecure by design. No, sorry. No, we have to face reality. So there is no authentication, no authorization, and anytime you can talk to those PLCs and RTUs and whatnot, you will be able to crash the process with malware. And for that reason, you certainly want to do your micro segmentation. And the bad news is the only way to do that in an efficient way is by starting with a functional analysis. And that does not imply that you have to reinvent the wheel, because there are existing models for that. And what do I mean by that? I'm talking about ISA 95. So you have a conceptual framework for that. And if you are also using the OT-based OT asset management system, this becomes fairly easily, because OT-base does allow you to structure your whole OT architecture using ISA 95 concepts or the modeling, right? So if we just look at this one side here, so you can see this is the systems view in the OT-based inventory. You can look at atomic devices, but for this discussion, it makes much more sense to look at systems, and this basically refers to ISA 95, where you would substructure your site into functional units, and that the level of granularity is pretty much arbitrarily. Usually, you would include work cells, as you see it here, right? So we have a larger entity, which is a body in white hall, if you will, and there you find different work cells, like the bumper production, etc. And now here's the cool part. So once that I've done that, I can ask OT-base to give me a profile to create the profile for this whole thing. And when I do that, it will also show me all the dependencies and, for example, the material flow. And this is what you need to arrive at a useful network segregation. Because now you would learn, as an example, well, I can, for example, protect all my hood, doors, bumper frames, stations, etc. But I should not forget about that support system, which may be something like pressured air or something, right? Or vacuum. Because if that thing goes down, well, multiple other work cells are affected as well. Okay, and it even gets better and better because OT-based will also draw you the network topology, taking into account those functional units. Okay, so you will see right away how your network is structured in respect to those functional units. Translate that with machine lines or plant components or whatever fits your specific needs. Okay, and then you could determine rather quickly where those lines go to, and if everything looks kosher, which it pretty much does in this example. So in other words, this tool is going to go a very long way for this purpose when it comes to network segregation. The other thing, when I just want to show you how an OT network actually looks in the real world. Okay, so we just picked this one here. And if you look at the address list here, what you see is, well, you know, that's a whole lot of different device types. So we have the PLCs, we have the sensors, we have the actuators, we have HMIs. And that, my friends, is what a real-world network looks like. According to Purdue, you would say, oh my God, we cannot do this. We have to segment all these device types out. And that is plain and simple nonsense. So this is what you would expect to find in a properly segregated network architecture. You have a bunch of PCs in there. You may even have actuators in there. Because this is all oriented about functionality. If one of these devices crashes, goes down, well, you know, the others won't be able to continue operations anyway. So this is microsegmentation, and what you should not do when you think about Purdue, don't do that horizontal layering. It's I would say a really bad abuse of Purdue. And with that, I'm going to leave you. But before we leave, let me point out, I know you can't get enough of Purdue. So just so you know, there are additional videos on Purdue on our channel. So if you go to YouTube, go to the OT-based channel, and there you find more stuff on Purdue. However, you will only learn the same story, the same insight over and over again. Okay, we don't have any comments today. That is a surprise because I was expecting heavy blowback by the Purdue fanboys. Well, maybe it will come later. Okay, see you next week.